In the next two movies, we're going to look at the way that attributes and operations of classes are represented in UML. We'll look at how they're displayed in compartments in the class, the visibility of both, types of attributes, return values and parameters, and derived attributes. Attributes represent the data held in classes, variously referred to as properties, member variables, data members, or fields in different programming languages. In a UML class diagram, we show them in the first compartment of the class, under the one with the name of the class in it. Each attribute has a name, and we normally use an initial lowercase letter for the attribute name. If we create a name made up of multiple words, we join them together without spaces and use camel case, where the initial letter of each word, apart from the first, is a capital letter. Each attribute has an indication of the visibility of that attribute, which will be used when it's implemented. The options are plus sign for public, minus sign for private, hash for protected, and tilde for package. Normally, we set the visibility of attributes to be private, so they can't be directly accessed by instances of other classes, unless we plan to subclass the class, in which case they're usually protected. Each attribute has a type, which defines the kind of data that can be held in the attribute. The types can be primitive value types, like Boolean for true and false logical values, or an int for integers. Or it can be a class, either from a library, like a date class, or from the same model, as in the example where device and timed event are part of the same system. UML has a built-in set of primitive types, which are Boolean, integer or int, string, real or double, and unlimited natural, which is the set of natural numbers together with the asterisk to represent when the upper limit of a range is unknown. If there'll be multiple values of the same type, for example held in an array or a collection, we can show the multiplicity of the attribute in square brackets. The example with 1, 2 dots and an asterisk here says that there must be at least one timed event, but there is no fixed upper bound on how many there may be. When an instance of a class is created, you can specify the default initial value that will be assigned to an attribute by specifying an expression which is separated from the attribute by an equal sign. In this example, enabled defaults to the value true. Sometimes the value of an attribute can be derived from other attributes and is not held as a data value. For example, a person's age can be calculated from their date of birth and today's date. There's no point in storing it because it changes every year. A derived attribute can be shown with a slash in front of the name. In the example, the duration of a schedule can be calculated from the start date and end date. Operations in UML represent the member functions, operations, or methods that will be implemented in program code and that can be invoked by reference to an instance of the class or the class itself if the operation is static. They're shown in the compartment below the attributes using camel case. Like attributes, each operation has a visibility of public, private, protected, or package. Normally, operations are public unless we plan to subclass the class, in which case they're usually protected. An operation may return a value when it's invoked. The type of this value is shown after the name of the operation, separated from it by a colon. If there's no return value, you can either use the word void or leave it blank. The name and type of each parameter for the operations can be held in the model, and they're shown separated by a colon. If there's more than one parameter, they're separated by commas. It's optional whether you show the name and type, just the name, as here, just the type, as here, or no parameters at all, as here. While some of the operations perform some specific algorithm, there are typically operations that simply get and set the value of each attribute, and these are often known as getters and setters. For a class with a lot of attributes, defining all the getters and setters in the model can make the diagrams unwieldy, so they're often left out. Some tools can generate them for you, especially those that do source code generation, and they'll generate the relevant operations for the target language, as in the two examples here for Java and C#. Now let's add some attributes and operations to our model. Here's the model showing classes with no attributes or operations. This reflects the content of the previous movie and the exercise that followed it. In EA, we can add attributes and operations by right-clicking on the class and selecting Features and Properties, and then either attributes or operations from the submenu. Let's add some attributes first. The Attributes and Operations dialog box appears. This is an area of Enterprise Architect that's changed considerably in the latest version. The dialog box is divided into 4 parts. On the left, I can select between attributes and operations. The top is where I add or edit the details of the attributes or operations, which are displayed in a table. In this case, we're working with attributes. The lower left is where core properties of each attribute can be set, and the lower right is where other properties and relationships can be set. The first attribute I'm going to add is called name. So I go to the field that says New Attribute, and I type in name. When I tab to the next field, it's added to the list. Notice that name has defaulted to be an int and private. The visibility is shown by the little padlock icon next to the name of the attribute. I can change that if I like by selecting a different value for the visibility from the drop-down list here. I want name to be private, so I'll put it back to how it was. I also want to change the type from int to string. So I type in string to replace int. Now I'm going to add enabled, which is a Boolean. I add it into the table where it shows new attribute. Enabled is a Boolean, a standard primitive type in UML, so I can select it from the drop-down list of types. Now I want to add device. In reality, the relationship between the schedule and device classes is going to be represented by an association. But I want to show you how you can add an attribute that is of a type that's in your model. I type in device as the name. Now I click on the drop-down list and I choose Select Type at the bottom of the list. This allows me to browse the model to select the correct class. I can find the device class in the domain package in my class view within the model. I select device and click OK. Device with an uppercase D is now set as the type for my device attribute, which has a lowercase d. Let's just have a look at what's happening in the diagram. I close the dialog box. Note that I didn't have to click a save after my additions, so Enterprise Architect has auto-saved the changes. Not all tools will necessarily do that. You can see in the schedule class that the compartment for attributes is now displayed, and the 3 attributes I added are listed here. Enterprise Architect defaults to listing them in the order that they were entered. I'll show you how to change that later. I now want to add a default initial value to enabled, so I want to go back into the attributes dialog. I can do that by right-clicking as I did before, or I can select an attribute and double-click on it. The enabled attribute is selected. I can go to the initial value field and I can select value, which because it's a Boolean is only allowed to be true or false. And I can set that value by clicking OK like that. I close this. You can see that that again has been reflected in the class in the diagram. We'll take a short break here and pick up where we left off in the next movie.